Welcome to Area DMG. I am your host, Phil Wesley, the Mile High Mouth, and today I'd like to talk to you about Project Tropic. What is Project Tropic? Well, it's based off the idea of an island. When you are on a desert island or a tropical island, you are not aware of, let's say you're in the middle of nowhere in a tropical island. You can see the island around you, and you can see the ocean around you, but your mind knows that there's other things beyond that ocean. There are other things beyond that blue ocean. And that's, even though you're technically lost, you can orient yourself by seeing stuff in the sky, by knowing there's stuff beyond those islands, and just generally knowing what you can't see. Now let's talk a little bit about virtual reality. What are the problems with virtual reality? Cost is a major problem with virtual reality, but that's come down over the years. That's good. Interest is another major problem, and right now there aren't that many compelling experiences with virtual reality because we tend to look at virtual reality as a gee whiz factor instead of a practical factor. Meaning it should be more of a practical thing. Not everything has to be first person. Not everything has to be some kind of shooter game or a first person game. Not everything has to operate in that way. It may be that the future of virtual reality would be the idea of a virtual office space, like a virtual Facebook thing. Well, once they figure out all those lawsuits, where here I am in my browser, and I look to my right, and I've got Twitter feed open up here. I look up here. I've got other things open. In other words, it's like the ability to give you infinite space to work in. That's basically the idea of a virtual space, to give you more actual, not physical, room to work with. Now, there is an issue with people getting sick from virtual reality. Now, one of the first forays in virtual reality that many of us had was the Virtual Boy from Nintendo. This did not use face tracking, which a lot of people tend to consider as the main reason for being sick from that. But I never had any problems with this one because generally my mind and the minds of a lot of other people when they're looking at stuff is that you're looking into a world that is essentially just right there in front of you. There's nothing to your left or to your right. It's all darkness. And the way this is, it's a closed space. You literally, to your left, to your right, there's just nothing, right? And you perceive that nothing, and it doesn't bother you. Now, one of the reasons they didn't go with a full color display on the Virtual Boy was cost. The other reason is what we're here to discuss. Part of the problem with stuff like HTC Vive, PlayStation VR, and other ones is that when you're using the head tracking technology, you're looking at the world through goggles, through these glasses. The world doesn't exist outside of these glasses. There is no indication of that. And that's kind of the problem. You see, humanity works a little bit like our vision works, where we can see stuff to a certain extent here, right? That's our visual cone. But we can sense things that are outside of our visual cone. We know they're there because even though they're right outside our visual cone, we see the influences of these items outside of it. In other words, if you're on that tropical island, you know that there's other stuff around you because everything around you, the water, is influenced by that. You can see the movements of it. You're not surrounded by still water. If you were on a tiny desert island and the water around you was dead calm, that would be very distressing because that would literally mean that you are in the place. Your brain would not be able to pull that and go with that. Like, wait, then that means there's nothing beyond this section here. It's just this. there's no waves, no nothing. But having those waves and having those other influences that we can't see, but we can see the effect of, allows your mind and allows your vision to pinpoint where it is. So what I'm saying is that the problem with virtual reality is how it's delivered. In order for 3D to work in virtual reality, you do need to have separate displays for both eyes. You need to have that sense of depth, because that's how your eyes operate. If you don't have that sense of depth, everything's a little bit flat, and it does tend to mess with your inner ear, or how your vision technically works. Part of your vision isn't just your ocular vision, isn't just your eyes. Part of what you see is influenced by what you hear, and we have directional sound for that, and part of what you technically sense. You see, we have things like sense of smell, sense of touch. There's sense of smell, sense of touch, eyesight, hearing, and we have these senses to tell us where we are, our spatial movement in actual reality. But the things that we can't see, we perceive with, I would say, an extra sense of motion, or a sense of perceived motion. It's more of a mental clarity. Meaning, I know my hands are behind me. They don't disappear when they're not in my vision. I know they're there because my mind tells me they're there, because I can sense their motion behind me, or I can sense that motion. And the problem with virtual reality, or rather with head tracking, is that there's nothing to pull for this. All you're seeing is stuff from here, or in a blinder. And this causes, this particular blinder causes this section of your hearing to not detect anything beyond that. And that's why your body disorients. How I suggest that we solve this is we go back to what happened with older televisions. There's a thing called overscan. Overscan is where you have, like, let me grab one of these. Let's say this is your picture, right? Let's say this is the entirety of your picture, but you could only see part of that. I'm going to have some examples using video games and using a moving video to give you a little bit of what I'm doing here. Let's say for a moment that you only saw, when you're looking into virtual reality, you're only seeing part of this. You're not seeing the whole picture, right? Unless you move up, then it moves the lens up and down. It moves what you're looking at by your lens, but not by the actual thing. This moves along with it, right? The way we currently see virtual reality is it's focused, and then when I move up, this moves with it. That's kind of how it works currently. A little bit disorienting because it's not how you technically see vision. When I'm looking at the world doesn't move with my vision. I move with it. And I can detect stuff that I've already seen because there's that little bit of residual information. How do we represent that residual information inside a virtual reality space? My solution is overscan, meaning you have your image, and then a little past that image is a distortion of what's happening there on that screen that is just right outside your visual range. In other words, when you're in a virtual reality headset, there's nothing here. But what if there were various lights that you could detect here that matched what you were seeing? In other words, like in virtual reality, let's say I'm looking at, say, I'm in a building, right? I see a wall in front of me, but I also see like some light reflected from that wall that's the same color of that wall over here. I'm not technically seeing it, but it's being projected over here. What we're talking about is overscan, similar to the Illuma room or the Ariana project that Razer proposed. The idea of here is a screen, and then outside of that screen is a bit of a distortion of what's happening on that screen to better immerse you into what's happening on that screen. So as you're moving along, you're seeing that world just kind of pulling in, kind of a vortex effect. And this particular effect is what you need in virtual reality. You need to have lights and other items that match what's happening on the screen but are not visible, technically. Up on the top, down below, and to the sides. In other words, I want to be looking at my glasses inside there, right? But I can detect that there's other stuff here. It just becomes less blurry as I look into it. And it has to be, it has to be at a point where you don't see the blur. You sense the blur of the light, but you don't see it. So the lights have to be here, or here, or here. And what I was thinking is we could solve this in a normal virtual reality headset by having mirrors, like a mirrored surface up here, a mirrored surface here, and a mirrored surface in here, along the edge and right outside, just right outside the vision of the player. So whenever they're looking at the light that's put through here, some of the light through carefully placed holes or carefully placed screen extensions could move. Like instead of having a screen that's actually rectangular, you have one that's actually more of a oval shape, or a longer, like, essentially what I'm asking is for, you want to show just the picture that's important, but have all the picture that's technically not important right outside that field of vision, be slightly blurred and reflected back here. So what I'm saying is that it would be a bit like ambiex, where they would have lighting that would match or change the room's lighting in correspondence with what's happening on the screen. If you've ever dealt with ambiex or IllumaRoom or the Ariana project that Razer is working on, the basic idea is this. I'm looking here, and then there are lights that are happening here. I can sense those lights, and therefore the world that I'm looking at here is extended here. And as I move my head, this does not change. Like this what's happening changes. Like what I'm viewing becomes unblurred, and then just like the part that's blurred is still out there right beyond my vision. And I feel that this may actually help with helping the inner ear and operate properly with vision to tell you that, oh, this is actually a physical space. While it's not a physical space, your mind will think it's a physical space if there are lights or representations of this non-physical space that are right outside of your cone of vision. I'm just saying you just need a couple mirrors along the edges, and that should work. I don't have the money to build any types of prototypes for this, or to test my theory until someone else does. But right now, the idea of Project Tropic is that that's what I would be doing. I would be proposing that we figure a way to use overscan and mirrors to project light just right outside of our visual cone, which lets us know that this world that we're staring at isn't just what we see in the lenses, it's further beyond that. And I feel that that may be where we need to go with virtual reality to fix the main problem with virtual reality, which is nausea. Now, I think HTC Vive had a headset that they showed at CES recently, and this particular headset also had a little thing which you could lock it into place, which I think is a great idea. However, the thing I didn't like is that while yeah, it had its built-in headphones, it didn't have anything on those headphones. They could technically take that and add an LED strip onto that part of that just reflects back in just ever so slightly from this end. Like let's say you're looking at a red object here on your screen, and then you move from the red object to a blue object. Now this part over here where the red object would be red. You'd be seeing a little bit of the residual nature of the red object. When you move back to the red object, you see a little residual nature of the blue object. That would give your mind the ability to process the limits of this particular world. I'm actually surprised that they don't do this. You could calibrate this quite easily by having it tell you what type of thing you want for overscan, and then just when you're testing this, look at red object, blue object, yellow object, green object, and then have the items around you correspond with that color, with that lighting, that light just beyond your visual cone. And that's what we need to make more compelling worlds. We need to think about how we see the world and how we perceive the world, and figure out how to replicate that without all of our senses. Most of the time you are just relying on seeing, a vision, and hearing. And those don't always work properly. Let's say you're playing like a horror game, and you have one with like ambient sound, like say Corpse Party. If you've got headphones on, you hear stuff behind you, but you're looking at something that's right in front of you. There's really no concept of the behind you in that. It would be nice in a virtual reality type thing where when you're looking at an item in front of you and you hear that thing behind you, let's say it's like an explosion, wouldn't you feel, or rather notice, ripple effects from the light given off to the explosion in your cone of vision? You would even note that there might be some light right beyond it, just right to the side. And that's really what I'm asking. We need to start looking at investing in making a more dynamic world via essentially light and mirrors. And I've got a couple examples of what I would feel that would look like in practice that I'd like you to take a look at. I have a couple slides about the way the eye looks, the way the eye works. And I hope that you look at this and think of it as, well, I think this is a good conversation to have about how this could benefit virtual reality in the future. How we can create a more believable world by creating and replicating what we don't see in a way that influences what we see. In other words, like let's say you put a flashlight behind me and you shine that light. I would see the effects of that flashlight even though I can't see that flashlight. And right beyond my visual cone, I could see a little bit of that brightness from it. And that's why I can detect that. That's why I have that spatial reasoning. And we need to think about that in particular. It's not that head tracking, there's a problem with head tracking and lag. We can work on that. But in order to make up for that, we may need to actually include kind of what they did with the N64 or early 3D games, where you have visual tricks to hide or mask or fog actual issues with hardware. And for this one, you might need to invest in some mirrors and light that's just right here where you won't appreciate what's going into it, but subconsciously you will. And that's what Project Tropic is. The theory that having reflective ambient lighting right beyond the visual cone can influence and better a virtual world and may reduce, in theory, nausea and that uncanny valley that your mind creates that tells you that where you are is not real. That's how we get over that, in my opinion. Let me know in the comments below what you think. Hit that thumbs up if you haven't already. Hit that subscribe button if you haven't already. Do check out a bunch of our science panels and educational panels. And do check out like all the great stuff that's virtually out there, you know. VR is going to get better. It's definitely getting better. And if we adapt or freely take, essentially, what I'm looking at, what I'm talking about. Maybe we can create this wonderful virtual reality for all of us that transcends nausea and then transcends that uncanny and takes us to that little virtual island where the water moves from unseen forces and where the light behind you tells you you are there. Hit that thumbs up, hit that share button, hit that subscribe button, ring that little bell to know when we have another video out. And until that next video comes out, you are now caught up. See, this is why I don't get to record as much as possible, because my camera crew is essentially this. And this little one seems to think that this is her chair.
Shut up and take my money!